Rules for obtaining images formed on a convex mirror. The first rule is a ray of light which is parallel to the principal axis. So here is a ray of light that comes parallel to the principal axis. After reflection, it will diverge because convex mirror is a diverging mirror, but it will diverge in such a way that it appears to come from the focus. This is the pole, here is the center of curvature, and this is the focus. So when after it reflects, it appears to come from its focus after a reflection. So I repeat again, a ray that comes parallel after reflection appears to come from the focus. So rule 2, here again we have the pole, this is the focus, this is the center of curvature. Remember, this distance should be equal. If you have taken 4 centimeters here, you need to take 4 centimeters here, which means while drawing the arc, you would have drawn an arc of 8 centimeters radius. Now rule 2, a ray of light going towards the center of curvature of a convex mirror. So here is a ray of light that is moving towards the center of curvature. So here, towards means after reflection, this ray of light will follow the same path back. So here it's reflected back along the same path. Let me take another ray coming from down like this, moving towards center of curvature. After reflection, it will reflect back along the same path. Now for rule 3, again this is pole, focus, center of curvature. Here we are talking about a ray of light going towards the focus of a convex mirror. So here is a ray of light that is moving towards the focus. After reflection, it will go parallel to the principal focus, the principal axis. So it becomes parallel to the principal axis. Let me take another example. Suppose it is coming from down like this, here, moving towards the focus. After reflection, it will move parallel to the principal axis. That is rule 3. Next is rule 4, a ray of light which is incident at the pole of the convex at any convenient angle. See if it comes here. It will get reflected also by the same amount, which means this angle of incidence will be equal to angle of reflection. However, we do not use this case as much. But if the ray comes at a particular angle of incidence, the angle of incidence will be equal to angle of reflection. So it's reflected back, making the same angle with the principal axis. Now that we know the rules, let us go to the formation of image of convex lens. What when the object is at infinity? If the object is at infinity, means the rays will come parallel to the principal axis. Like the sun is an object at infinity, very far away, the rays come parallel. And let us mark our pole, this is the focus and center of curvature. Now remember that this is a convex mirror, it's a diverging mirror, and the rays that come parallel, in this case, the rays that come parallel, after reflection they appear to come from the focus. We do it down again, rays that come parallel, after reflection they appear to come from the focus. So these rays that have come parallel, after reflection they will all appear to come from the focus. They will get reflected this here, they will all appear to have come from the focus. So the image will be formed at this point, at the focus. It will be a highly diminished image formed at the focus. It is virtual because it is behind the mirror. So image formed at focus. It is a virtual images are erect, highly diminished. So this is example like the image of the sun, image of a faraway object will be formed at the focus. Here object in front of the mirror. So we have the pole, focus, center of curvature. Here is an object kept in front of the mirror. So we name it like A, B. Now to find the image, we always draw two rays. We'll draw one ray that is parallel and one ray that is heading for the center of curvature. So that ray would be something like this. Now the ray that is parallel to the principal axis, the blue ray which is parallel to the principal axis, after reflection will come from the focus. So it will appear as if it is coming from the focus. So this will be its direction of the blue ray. And the one that is heading for the center of curvature the green one will retrace its path. So you have seen both the rays meet at this point. So the image will be formed here, but this is a virtual image. So the image will be here A dash, B dash. So if you see the features of the image, it is virtual. All virtual images are erect. It is diminished, which is much smaller than the object. It is formed behind the mirror. So these are the characteristics of the image: virtual erect, diminished, formed behind the mirror. These convex mirrors are used as rear view mirrors in cars and vehicles. Like in this picture you can see, when you look in the rear view mirror, everything looks smaller. So there's a wider view. The driver gets a wider view of the traffic behind him. So why are convex mirrors used as rear view mirrors? Number one, they always give an erect, diminished image, and the driver then gets a wider view of the traffic behind him. They also are bulging, they're bulging outwards, and because they are bulging outward, they give you a much better view. They are bulging outwards, so they give you a better view of the traffic behind. However, there's one drawback in these mirrors, and the drawback is objects look closer than they actually are. Objects seem closer than actually are. This is the precaution, this is the disadvantage. So it is not only used in rear view mirrors, you use it in supercenters, on roads, because it makes the picture much smaller, it makes the object much smaller. So a large amount of area is fitted in a small mirror.